Consider the graph of y equals 4 cosine 2x. Before we dig into this, I'm just going to sketch y equals cosine x so we have something to compare this against. Cosine x, well, cosine 0 is 1. Cosine 90 degrees, or pi by 2, is 0. The cosine of 180 degrees, or pi, is negative 1. The cosine of 270 is 0. And the cosine of 2 pi is 1 again. So your basic cosine is a wave that starts at a maximum, drops, bottoms out at negative 1, recovers, and is back at maximum by the end of 2 pi. Because its hills are 1 unit high and its valleys are 2 units deep, we say that the basic cosine function has an amplitude of 1. And because it takes from 0 up to 2 pi to get through a complete cycle, we say it has a period of 2 pi. You'd think we would use the letter P for period, but because it's often a unit of time when we measure it in physics or chemistry, they tend to use a capital T for the period of a wave. So now, what if we have, instead of just cosine x, we have 4 cosine 2x? What differences do those make? Well, the first one's easy. This multiplier out front, which we often call A, is the amplitude. So, in this case, the amplitude is 4. If this were 10 cosine 2x, then we'd have an amplitude of 10. If this were minus 6 cosine 2x, we'd say the amplitude is 6. And if there is no number written here, then it's understood to be an invisible 1, and we would say the amplitude is 1. That's what happened with our original cosine. The period is a little less straightforward. It isn't 2. The 2 is related to the period, but it isn't the period. The period is always 2 pi divided by b, divided by the multiplier on x. So in this case, it's 2 pi divided by 2. So our period in this case is just pi. We have an amplitude of 4 and a period of pi. Now if you sketch that, how is that different from this wave? In 2 ways. First, instead of our peaks being 1 unit high, they're going to be 4 units high. So we're going to have a max at 4, and our minimum is going to be at minus 4. Second, this wave is not going to take all of pi to get through a cycle. It's only going to need pi. Sorry, I may have just said it takes 2 pi for cosine to get through a cycle. For this wave, it's only going to take pi. Sorry if I misspoke there. So we have to get through an entire cycle in only this much space. That means halfway through that amount of time, we should be all the way down at our minimum at negative 4. And so our new wave has to look something like this. It has to drop, get to minus 4, and now by the time we hit pi, I have to be all the way back up here. So I've got a square and a half to get to the midline, and then another square and a half to make it to my max. And if they want us to cover the entire grid, we could draw all of that again. There we are, back down to midline. Halfway through the cycle, we're at our minimum, and now I have a square and a half to get back to the midline, and another square and a half to get back up to the max again. So a 4 means this new wave is 4 times as tall. A 2 means this wave is twice as fast. It gets through 2 cycles instead of just 1 in the same amount of time. And you can use a graphing calculator and key in y equals 4 cosine 2 times x, and you should get a shape just like this.